This video will continue our discussion of vectored value functions. We're going to work on graphing these things, getting a sketch of a curve that's represented by one of these functions. Okay, so I gave you some steps here. You'll see the steps will make more sense once we get into an example. So the first thing I always do, this is a two-dimensional, I have an I and j, no k. Identify x and y and z from the function. So what I mean by this is that I have x is the square root of t. I also have y is 2 minus t. Okay, so I identified those, and then we're going to use one or more of the components, and we're going to replace to find a function. So what I mean by that is I want to find a way to maybe plug t into the other function to get rid of t. So I'm going to solve here for t, and then we're going to replace this into this function. So I'll draw some arrows, so hopefully to help with notes. So y equals 2 minus x squared. I replaced t with what I solved for. This allows me to see what this is. I hope you guys can tell. This is a parabola. Reflected vertically. Because of the negative. And then shifted up 2. Alright, so I'm going to graph that. I'm going to let these be 1s. Just kind of help me out. Because if not, the graph's going to be kind of small. So we'll say this is 1. And that is 1. Okay. So it shifted up 2. So let me grab another color here. We'll do it red. Up 2. And then I know the normal parabola goes over 1, up 1, or down 1 in this case since it's reflected. Over 2, I go up 4. So let me put some more in there so we can see what it looks like. It's negative 1, negative 2. So if I plug in 2 into this function, we get negative 2. And then we know parabolas are symmetric, so we have that. So I'm going to go ahead and draw my parabola here. And when you do this, we're going to want to do it in a dotted line right away at the beginning. Vectored value functions, what makes them very great for us, I missed there. Let me try that again. A little better. What's great about a vector value function is not only does it describe this path, it actually describes an orientation, meaning it's a path that's being traveled on as t is going, and we actually were given this stipulation. T is greater than or equal to 0. So what we're going to do from here is we're literally going to just plug in. Let me get off this. T equals 0. We'll figure out where that starts. So r of 0 is equal to the vector 0 and then 2. So it points at my point from standard position. So it starts here, and it looks like it's going to go 0, 2, so it actually starts up there. I'm going to erase my vector, but that's what it's pointing at. So in my graph, this is why I did a dotted line, is I know it starts right here, okay, and I want to see where it's going to go. So I do t equals 1. So r of 1. Plugging in 1, we got 1, 1. So it points, the vector points right there, telling me that's where my point is, and that describes the orientation. So I know this curve goes this way, so I'm going to fill it in, and we could put in arrows to describe the movement. The movement starts at the very top, and it goes to the right. So that's why I did the dotted line for the parabola, is because I know the curve, I know the vector value function is on that curve, but it doesn't mean it's defined on the whole thing. It's based on t. So I used t to tell me which way it's going and where it starts. All right, so let's do another one. We're going to do one in 3 space. So let's check this out. All right, so first thing I always do is I go ahead and identify x, y, and z. So x is 3 minus t, y equals t plus 2, and z equals 3 minus 2t. So looking at this, I hope something triggered in your head. Maybe if I put this here, it looks a little better. This is a line, right? This is the exact, these are parametric equations of a line. So let's write that in, parametric equations of line. Guess we could put of. Oof, I'm going to redo that because it looks real bad. Okay, parametric equations, not better, of line, of a line. Okay, so I know it's a line. Now, this is how I'm going to graph this part, is we actually can just plot points and find them. And how many points do we need to define a line? I hope you're saying 2. So I'm going to find 2 points on this line. Let's do t equals 0. So if I plug t equals 0, r of 0 is equal to, all right, we got 3, 2, 3. So I'm going to plot that. All right, 3 in the x, so out 3, 2 in the y. So let's do a dotted line there. I'm going to do this to help me out. I'm going to draw, if you have a ruler, this is how we would do that. So take your ruler, make sure it's the same as that. I'm going to move that dotted line now if I can grab it. There we go. And I'm going to make it go through 2. So I know it goes out 3. And I also can do this. Draw a line this way. Make it flat. Move that down to here. And I can see where 3, 2 is going to intersect. So I'm actually going to put a solid X there. Oops. All right, and then I can go up, it's 3. So up 3. So I do maybe like a dotted line, solid line. I'll use that here for a moment. I know it has to go up to 3. Maybe it's out just a little bit. Let's do it right at 3 just to help. So here's my point. I'm going to go straight up from here. Make my line straight. And it's this point right there. And then I erase those. We could do a dotted line here to describe that it is out there. And then I'm going to go ahead and erase these and put lines there to help. I know I'm doing a lot of work, but I really do want it to look like what we're talking about. So it looks like maybe a little off. I think we could make this go a little further, maybe up this way. We'll call it good. Okay, so you can see that point. We also need another point. So I'm going to do t equals 1. So r of 1 is going to be 2, 3, 1. So I'm going to use that same method to plot this. So at 2, 2, and then 3. So I'm going to draw a line, or you can use a ruler. So I know it goes right there. Oops. All right, and then we also know that it is at 1. So I'm going to draw a flat line there. And I know the point goes right above it. So there's my point. And then I'm going to erase these. Draw my dotted line so we can see where that point is at. It was at 2. Okay. Let's shorten that. 2. And then at 3. There we go. So there are my 2 points. You can kind of see them in 3 space. And if I'm trying to create a line, I'm going to just start at 0. So that was this one. And I'm going towards the other line. Let's do it solid color. Change the color so we can see it. Do it red, solid. Starts here, goes on that way. That's a nice line. There we go. Goes towards that direction. It's kind of hard to see where it's going, but I know it's here, and the path goes this way. They really didn't give me a t, saying t equals 0, so really the right thing to do would be to continue this line. And we just know orientation goes that way. We can I know t usually represents time, but time can, in a mathematical realm, t can be negative. In a physics realm, if t was time, then we would have a problem. We don't talk about going back in time. So, but in a mathematical sense, we can talk about going back in time because we didn't specify t is time. T could be a lot of things here. So there's my 3-dimensional graph of this line in 3 space. draw each point, connect the points, and that'll be your line.